Dear learners of control systems, I welcome you to the session on Matlab simulation. To do the Matlab simulation online without installing in the system or the laptop, we have to use the URL https://matlab.mathworks.com. So if you type that URL, it will ask for sign in. Then you may have to actually create your account. So you have to create your account. So write the email ID, type the email ID, then it will ask for creating password, all that. Then if you go according to the instructions given, you can create your MATLAB login. After creating the MATLAB login, just sign in. For example, I am signing in from my local ID. So ganesh.rit.chennai.edu.in. So this is my login. So I am just typing my password. So after typing the password, I am just signing in. Now it has gone to Matlab. So use Open Matlab online. So it is getting connected to the online version of the Matlab provided by the MathWorks company. So you can see here home, plots, apps, editor, publish, file versions and view. So what you can do is you can actually open a new script. You can open a new script. In that file, you can create a particular program. So new script is a file. For example, let me type MATLAB program for the unit step response of a first order system with the transfer function. Here I have put percentage symbol and I have written typed MATLAB program for the unit step response of first order system with transfer function. So whenever we use the percentage symbol, so it will appear in green. That means this particular line won't be executed. So next what I do is I am just typing the transfer function for which I need the MATLAB simulation. For example, the closed loop transfer function of a first order system 1 by 5s plus 1. So you know very well that this is of the form 1 by ts plus 1. So if you have gone through my lecture videos in Dr. C. Ganesh teaching module, so there is a video on time response of first order system. So you can see time response of first order system in the playlist in control system lecture series. So if you go to Dr. C. Ganesh teaching modules, then probably it will ask for the playlist. So in that playlist, what you can do is control system lecture series is there. So you can view the full playlist. In that the time response of first order system, that is lecture 5. So if you type that, so it will give you an information regarding the theoretical explanation for time response of first order systems. So if you have already gone through that and if you have understood, then you can just proceed with the MATLAB simulation that I am doing. If not, you please go through that video and then come back. Then you will be in a position to better understand the terms that I am going to introduce in my presentation. Now let me move on to the MATLAB simulation. So this is the transfer function. So this transfer function, I need to create a program. So here I have put percentage symbol because this also I don't want to execute. 1 by 5s plus 1 is in the form 1 by ts plus 1. Next what I am doing is I am typing this numerator. So numerator, just for my reference, I am putting NUM equal to 1. So here I have given the explanation also, numerator of the transfer function within percentage. So when I put percentage, whatever I type after that in that line won't be executed. So NUM equal to 1, that means numerator of the C of S by R of S is this. Then denominator 10s plus 1, to get the 10s plus 1. So denominator I am typing DEN equal to, normally we have to put square bracket, then coefficient of S, then constant coefficient. So you can see here. Then I should assign this for the transfer function. I should assign this as a transfer function. So you can see here. So SYS, I am assigning this as system transfer function. TF is actually a keyword. TF within brackets, curved bracket, NUM comma DEN. That is to form transfer function. That means this 1 will be taken as the numerator. 1 will be assigned as 10s plus 1. That will be assigned as transfer function. That's the idea. Next, I want to find out the step response of this system. So I am typing step of this, that is step within brackets SYS. So here I have written what is that, to obtain the step response plot. Now I am saving this. So I am saving this, save as. I am going to save this as exercise for practice. So xprac I am putting, save. Right. Now I am running this. So if I run this, I will be able to see one response as figure 1. You can see here. So figure 1, you can see response. See, we know that the time constant is 10. How to check it? Before that, what is the transfer function? So let me put SYS here. This is called command window. In the command window, if you put SYS, it is showing 1 by 10s plus 1. That is what I said. This is assigned as transfer function. Now I think it will be clear for you. So if you want to see exactly what is happening here, so you place the cursor. You place the cursor and move the cursor, and you can see exactly at 10 second, you can see corresponding to 10 second, you will have 0.632. That is, amplitude will be 0.632 corresponding to 10 seconds. That is what I have kept here. So corresponding to 10 seconds, the amplitude is 0.632, means the time constant is 10 second, actually 1 by Ts plus 1. Actually it is 1 by Ts plus 1, right? So 1 by Ts plus 1. For example, if you put CLC here, what does it show is clear the screen. So now if I put SYS here, it will show you the same thing, 1 by 10s plus 1. This 10 is actually the time constant, because the closed loop transfer function is the form 1 by Ts plus 1. So 10 second means step response, we know it is rising from 0 to 1 from my theory explanation. So for that you refer this control system lecture series video 5. Then probably you will be in a position to understand at 10 second it reaches the 6 point, that is 0.632, that is 63.2 percentage of the final value. Final value is 1. Steady state it is reaching 1 because it is rising from 0 to 1. So this is what I wanted you to understand. Now you can see here I am changing the time constant. Instead of 10, I am giving 100, and again I am running. What happens? So you can see for reaching the same 0.632, it is taking 100 seconds. So what does it mean? So almost 100 seconds, yeah, 0.632. You can move the cursor properly, yeah, you will get 100 seconds. You can check it out, right? So that means it takes more time to reach the same value, 0.632, that is 63.2 percentage of the final value. Suppose instead of 100 second, I am giving 0.1 second, let us say 0.1. Now I run it. What happens? Yeah, 0.1 itself you get 0.632. So that means lesser the time constant, it takes lesser time for the response to reach 63.2 percentage of final value. That is 0.632 is a 63.2 percentage of final value. So this is what I wanted you to understand from the Matlab simulation. So our job is made easier by checking all these things through Matlab simulation. So Matlab facilitates us to realize what we have mathematically understood. Hope my explanation would have facilitated your learning. Thank you.